In the last lecture, we discussed the construction and working of Wheatstone Bridge, and there we understood the balance condition. The bridge is in balanced state when the product of resistances of the opposite arms are equal. That is, when you multiply R1 and R4, which are the resistances of the opposite arms, and when you multiply R2 and R3, which are also the resistances of the opposite arms, and when you find them to be same, then no current will flow in this branch. And therefore, while calculating the equivalent resistance, we can neglect the resistance R5. So this is the balance condition when we have resistors in our bridge. Now we will understand what will be the balance condition when we have impedances in place of resistances. And we know what is an impedance. An impedance represented by Z is the effective resistance offered by the combination of resistor along with inductor, or the combination of resistor along with capacitor. And therefore, to generalize the case, we have taken black boxes representing our impedances in the bridge. Z1, Z2, Z3, Z4 and Z5 are the impedances, and we know impedance is a complex number, therefore it will have the magnitude and also the angle. Now let's say that Z1 is having the magnitude mod Z1 and the angle is theta 1, and Z2 is having the magnitude mod Z2 and the angle is theta 2. Z3 is having the magnitude mod Z3 and the angle theta 3, and Z4 is having the magnitude mod Z4 and the angle is theta 4. Now according to the balance condition, Z1 multiplied with Z4 must be equal to Z2 multiplied with Z3. So Z1 multiplied to Z4 should be equal to Z2 multiplied to Z3, and Z1 is equal to this. So we have mod Z1 angle theta 1, then we have mod Z4 angle theta 4 equal to mod Z2 angle theta 2 mod Z3 angle theta 3, or we can say mod Z1 multiplied to mod Z4. The angles will get added, so we have total angle on the left hand side equal to theta 1 plus theta 4, and on the right hand side we will have magnitude multiplied together, so mod Z2 multiplied with mod Z3, and the angle will be theta 2 plus theta 3. Now on comparison we can see that mod Z1 multiplied to mod Z4 must be equal to mod Z2 multiplied to mod Z3. This is one condition, and the next condition is theta 1 plus theta 4 should be equal to theta 2 plus theta 3. This is condition number 2. So when we have the impedances in our bridge, then there are two conditions which must be satisfied to balance the bridge. The first one is the magnitude condition. Magnitude condition must be satisfied, and the second one is the angle condition. Angle condition must also be satisfied. And now I will give you one homework problem based on our discussion. Here we need to find the value of Z4, for which the bridge will be balanced. Z1 is given, magnitude is 10, angle is 30 degrees. Z2 is given, magnitude is 5, angle is minus 50 degrees. And the third impedance is also given. Magnitude is 4 and the angle is minus 40 degrees. There are 4 options, and most probably you won't be able to solve this problem. You will find the answer which is wrong. So in the next lecture we will solve this problem, but before that I will advise you to solve it on your own. And whenever we have the balance condition satisfied, then the current through this branch is equal to 0, and in that scenario we will neglect Z5 impedance. So this is all for this lecture. Remember the magnitude and the angle conditions.